Hello, hello students. Today we will read 9.1, the trigonometric application, and the question number 1 is: a circus artist is climbing 20-meter long rope, which is tightly stitched to the top of a vertical pole on the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degree. Let's take a pole AB, that is A, B, and it is the ground, and this is the rope, that is 20 meter at the position is C, and the angle made is 30 degree. So given the length of the rope is equal to 20 meter, or is equal to AC is equal to 20, and angle at the ground is equal to 30 degree. C is equal to 30 degree. To find the height, we have to find the height of the pole AB. In triangle ABC, sine 30 degree is equal to AB by AC. Here we have to find the here we have to find sine of the angle, because we have to find the P. As we know, sine theta is equal to P by H. H is given, and we have to find the P. Or is equal to sine 30, the value of sine 30 is half, is equal to AB by AC, or implies 2AB is equal to 20. AB is equal to 20 by 2, or is equal to 10. Now question number 2. A tree break due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 with it. The distance between foot of the tree and the point where the top touch ground is 8 meter. Find the height of the tree. Here we have to find the actual height of the tree. So let's A, B, C is the height of the tree. It is broken from B and touches the ground like that. That is D. And the distance from the point where it touches, and the distance between the foot of the tree and the point where it touches is 8 meter. So let AC is equal to height, actual height, AB is equal to broken height, which makes an angle 30 degree. So in triangle ABD, tan 30 is equal to AB by AD. Here we have to find out tan 30 because tan theta is equal to P by B. B given, we have to find out the P. Or tan theta is equal to 1 by root 3 is equal to AB by 8, or AB is equal to 8 by root 3 meter. Now we have to find out BD, the broken part. For that, in the same triangle ABD, cos 30 is equal to AD by BD, or is equal to root 3 by 2 is equal to 8 by BD, or is equal to BD is equal to 16 by root 3. Now height of the tree is equal to AB plus BD, or is equal to 8 by root 3 plus 16 by root 3 is equal to 24 by root 3, or is equal to 8 root 3 meter. Third question is, a contractor plans to install two sides of the children to play in a park. For the children below the age of 5 years, she preferred to have a slide whose top is at a height of 1.5 meter and inclined at an angle of 30 degree to the ground. Whether for the elder children, she wants to have a steep slide at a height of 3 meter and inclined at an angle of 60 degree to the ground. What should be the length of the slide in each case? We have to make two figures, figure A and figure B. Figure 1 and figure 2. In figure 1, we have height is 1.5 meter and the angle is 30 degree. That is, AB is height and the C is the AC is the slide. And in figure 2, PQ is the height, that is 3 meter, and PR is the slope, that is 60 degree. Here in figure 1, AB is equal to height, that is 1.5 meter, AC is equal to slope, triangle ABC sine 30. Here we have to find sine 30 because we have to find the P. Here also P. Here also, H, the hypotenuse. Here we have to find the hypotenuse H. So sine 30 is equal to AB by AC, or is equal to half is equal to 1.5 by AC, or is equal to AC is equal to 3 meter. Similarly, in figure 2, PQ is equal to 3 meter, height and angle of the slope is equal to 60 degree. So P in triangle PQR sine 60 is equal to PQ by PR, or is equal to root 3 by 2. The value of sine 60 root 3 by 2 is equal to 3 by PR, or is equal to root 3 PR is equal to 6. PR is equal to 6 by root 3, or is equal to, we have to multiply root 3 here and root 3 here. That is 6 by 3 into 3 root 3, or 2 root 3. Hence the heights and the slopes are, hence the slopes are 3 meter and 2 root 3 meter. Now question number 4. The angle of elevation of a top of a tower from a point on the ground which is 30 meter above from the foot of the tower is 30 degree. Find the height of the tower. So according to the question, AB is the tower, C is the distance from the tower, that is 30 meter, and the angle of elevation from C is equal to 30 degree. So we have to find out AB. Here AC is equal to 30 meter. The angle at C is equal to 30 degree. So in triangle ABC we have to find out tan 30. Tan 30. Why tan 30? Because we have to find out P, the perpendicular. So tan 30. Tan 30 is equal to AB by BC, or is equal to 1 by root 3 is equal to AB by 30, or is equal to root 3AB is equal to 30. AB is equal to 30 by root 3, or is equal to 30 into root 3 divided by root 3 into root 3, or is equal to 30 root 3 by 3 or is equal to 10 root 3. Hence the height is 10 root 3 meter. Answer. Now question number 5. A kite is flying at a height of 60 meter above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string assuming that there is no slack string. That means let's take AB is the height of the kite, that is 60 meter, and the string attached at C with at an inclination of 60 degree, and assume that the no string is slack. That means the string is straight. So here we have to find out AC. So AB is equal to 60 meter, angle at C 60 degree. So in triangle ABC, sine 60 is equal to, as we already discussed, why we have to find the sine 60 in this case. Sine 60 is equal to AB by AC, or is equal to sine 60, the value of sine 60 is root 3 by 2 is equal to 60 by AC, or is equal to root 3 AC is equal to 120, or is equal to AC is equal to 120 by root 3. That implies 120. Here we multiply root 3 above and root 3 below. That implies 120 root 3 divided by 3. 3, that is 40 root 3. So the length of the string is 40 root 3 meter. Now the question number 6. Question number 6 said 1.5 meter tall boy is standing at a some distance from 30 meter tall building. The angle of elevation from the eye of the top of the building increases from 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building. Let AB is the height of the building, C is the first point of the child where the angle is 30 degree, and D is the second position of the child where the angle is 60 degree, and CE is the height of the child, that is 1.5 meter. And EG is the distance of the child from the building. Now here AG is the height of the building. C is height of child. EG is the distance of child. Angle of elevation at C is equal to 30 degree and at D is equal to 60 degree. The height of the building is 30. Here AB is equal to AG minus BG, that is equal to 30 minus 1.5, because CE is equal to BG, that is equal to 28.5, that is equal to 57 by 2. In triangle ABC, in triangle ABC, tan 30 is equal to AB by BC. That implies 1 by root 3 is equal to 57 by 2 BC. 1 by root 3 is equal to 57 by 2 BC. That implies 2 BC is equal to 57 root 3. BC is equal to 57 root 3, 57 by 2 into root 3. Now, in triangle ABD, tan 60 is equal to AB by BD, that is equal to root 3 is equal to 57 by 2 BD. BD is equal to 57 by 2 root 3, that is equal to BD is equal to 57 by 2 root 3, that is equal to 57 into root 3 divided by 2 into 3, that is implies 57 root 3 divided by 6, that is equal to 19 root 3 by 2. 19 root 3 by 2. If we observe the figure, here we have found CB, we have found BC, and we have found BD. Now, by subtracting BD from BC, we will find CD. That is equal to CD is equal to BC minus BD, that is equal to 57 root 3 by 2 minus 19 root 3 by 2, that is implies 38 root 3 by 2, that is implies 19 root 3 meter. Hence, the boy walked a distance 19 root 3 meter towards the building. Now question number 7 is, from a point on the ground, the angle of elevation of a bottom and the top of a transmission tower fixed at the top of a 20-meter height building are 45 degree and 60 degree respectively. Find the height of the tower. So first we take the building, the height of the building is equal to AB, and the tower above the building is equal to BC. And D is the point of or angle of elevation. D is the angle of elevation. The angle of elevation to the top of the building is 45 degree and the angle of elevation to the top of the tower is 60 degree. Now we have to find the height of the tower. The height of the building is 20 meter. Here AB is equal to height of the building, that is 20 meter. D is the elevation angle point. So the distance AD is equal to, in triangle ABD, tan 45 is equal to AB by AD, or implies the value of tan 45 is equal to 1, that is AB by AD, or implies AD is equal to AB, that equal to 20 meter. Similarly, in triangle ACD, tan 60 is equal to AC by AD, or is equal to, or implies tan 60 is equal to AB plus BC by AD, or implies tan 60 is equal to root 3. Root 3 is equal to 20 plus AB by 20, or implies AB is equal to 20 root 3 minus 20, or AB is equal to 20, if you take 20 common, that is root 3 minus 1 meter. So the height of the tower is 20 root 3 minus 1 meter. Answer.